Good morning. Welcome to Technical Writing Webinar Series 2. We had a very good presentation last time, and Professor Xiaoming Shi from Washington State University gave an excellent presentation on 6 key elements of high-quality technical writing. And today's webinar, Dr. Jie Han will give a presentation from a different perspective, how to publish well-written technical papers. The Technical Writing webinar series is co-sponsored by Center for Environmentally Sustainable Transportation in Cold Climates, International Association of Chinese Infrastructure Professionals, and University Transportation Center on Inspecting and Preserving Infrastructure through Robotic Exploration. And again, we will have presentation first, and if you have any questions, please input your questions into the question box, and we will answer all questions after presentation is completed. I think we received a lot of feedback from first webinar. I think Dr. Han will answer more questions through today's webinar, and also after that, we will post recorded webinars and PDF version of presentations, CESTiCC, Aace, and Inspiring website. So probably most of you guys are expecting this, and so after both done, and we will post all information on the websites. And today it's my great pleasure to invite Dr. Jie Han from University of Kansas to give the second technical writing webinar. Dr. Jie Han is the Glenn Parker Professor of Geotechnical Engineering in the Civil Environment and Architecture Engineering Department at the University of Kansas. He has 30 years of teaching, research, and practical experience in geotechnical and pavement engineering. And he, as the sole author, published the book Principles and Practice of Ground Improvement in 2015, and has authored or co-authored more than 350 peer-reviewed journal and conference papers. And he has been invited to deliver more than 200 keynote or invited lectures at many international events. Dr. Han is the chair of SC Geo Institute Soil Improvement Committee and served as an editorial board member and associate editor for SC Journal of Geotechnical and Geoenvironmental Engineering and the SC Journal of Materials in Civil Engineering. He has received numerous awards, including Shamshir Prakash Prize for Excellence in Practice of Geotechnical Engineering in 2011, International Geosynthetic Society Award in 2014, and SCE Martin Cape Foundation Engineering Award in 2017. Today, and Dr. Han will share his years of experience and experience in details about issues in paper writing and general guides. Dr. Han, it's your turn now.
Okay. First, thank you, Professor Liu, for the nice introduction. And also thanks all the organization sponsor this event. And thank all of you listen to my presentation. So I think I intentionally put the title with the word publish here. What I will address not only how to write technical paper, but also how to publish technical paper. So here's the outline of my presentation. Start with the introduction, then talk a little bit about paper publication and the review process, and then talk about key elements for technical papers. Then I'll focus on the presentation of technical writing, and then talk a little bit about review comments and the revisions, and at the end, some concluding remarks. I think my presentation complement Professor Shi's presentation very well. He gave an excellent presentation on the 6 key elements that you already learned those important things from him. That I will get into a little bit detail about some issues I learned through the process of editor board member and also advising students and learn from others. Now, I have a little bit disclaimer here. First, as you can hear from my accent, I'm not a native English speaker, and I not pretend to I'm the expert in English. However, I have published more than 300 technical papers, mostly in English. This presentation was prepared based on my personal experience and opinions through 20 years editorial board service and advising graduate students, and also technical paper writing, include authorship or co-authorship in geotechnical engineering. But here I emphasize my presentation will mostly use the examples in geotechnical engineering. However, there's a similarity between different fields. But also you need to understand that different fields, journals or conference may have different rules and styles for technical papers. The guidelines I present or discuss in this presentation may not be all applicable. But you need to take this into mind when you listen to my presentation, or even after this presentation, review my talk. Now, let me talk a little bit about technical paper versus fictions. And in my opinion, technical paper should contain facts with evidence and the supporting theory of data. Technical paper should be written in plain language with simple words that are easy to understand, do not need any imagination. But I highlight 3 words here: should be simple, then not require imagination. Now, fiction does not necessarily contain facts. Fiction may be written in a rich, colorful language with difficult or vague language words that require imagination. The vague is very important for fiction, and the imagination also important. But for technical paper, has to be simple, clear, does not cause confusing to readers. This is a very big difference between those 2 types of writing. Now here I list my top 10 most cited papers from Google Scholars. And the first most cited paper basically on the top, and then go down to the bottom from 560 to 101. And I want to highlight something to make some point. Here basically the 3 top papers, top cited technical paper I wrote. And I think this is consistent with what I think the most important paper I have published. And then if you look at journals, you can see this is a Journal of Geotechnical Geoenvironmental Engineering. But among 10 papers, most cited papers, 6 basically published on the Journal of Geotechnical Geoenvironmental Engineering. There are 2 published on geotextile and the geomembranes. Those are very special journals. But if I compare with the impact factors, and basically consistent with those highest impact factor for those 2 journals among the geotechnical engineering journals. However, I'm not a big fan of the impact factors. Then from this analysis, you can see they do have some implications. But when you select papers, the impact factor can be a reference value for you to consider, but it's not necessarily you have to publish to high impact journal. But there is some correlation based on my 10 top most cited technical papers. But this is a brand new information. I will show you the impact factor and the acceptance rate of Aace Journal of Geotechnical Geoenvironmental Journals. And as you can see, from 2010 to 2017, the number increased significantly. But at the same time, actually, the percent acceptance rate is going down. Okay, because I think more and more people try to submit papers to the top journals like this one. And from here, you can see the range from 15% to 35% range in the last 10 years. But I try to correlate the percent acceptance rate to difficulty through this way. If the acceptance rate is less than 10%, it's extremely difficult, maybe like a science journal. And less than 20% is very difficult. As you can see, in the last 3 years, this journal is around the 20% range. It's very difficult. Less than 30% is difficult. Less than 40% okay. Greater than 40% is easy. What kind of journal will consider to be easy? Typically, those open source journals, those new journals just come up to the market, and they try to attract more paper into the journal. Those journals typically relatively easy. Now, authorship is very important, and I know a different country researchers dealing with these things a little bit differently, but as I know, in the United States, this is very serious business. The author on a paper should have made technical contribution to the study presented. If the author does not make any contribution, should not be on the paper. But all authors should approve a manuscript before it is submitted. You cannot just write papers and put the other people's name, just submit it. Especially like with students or new writer or new researcher try to rush to publish a paper and without consulting with advisor or the co-author, that's not right. This is not professional. Rushing publication submission often result a paper to be rejected or declined or delayed in reviews. You try to speed up the process, often result in delay in the publication of reviews. So the corresponding author is the author, represent all the co-authors for corresponding during the paper submission, revision, future inquiries, and also include the citing a copyright release forms. Now I want to show you one slide here. I'm very fortunate to work with Dr. Drew, is one very famous professor in geosynthetic field. And I work with him. You see that how many times we revise the papers. Here's the version 82. Okay, this is extreme. I don't expect that all the people will write paper up to 82 and then submit it. But this is one case I did with Dr. Drew. I learned a lot from him through the process, writing and improve writing papers. Okay, let me talk a little bit about publication process of ASCE journal, Geotechnical Geoenvironmental Engineering. I want to make it clear, I'm not represent the ASCE Geotechnical Geoenvironmental Engineering journal. This is purely my own summary of the publication process. Here, the manuscript submission to public office, then the publication office will distribute to the editor-in-chief, and the editor-in-chief will assign to editors. Then editor will assign to associate editor, and then the associate editor will select and distribute the paper to at least 2 reviewers. The associate editor can serve as third review by himself or herself. And then after review come back, the associate editor will summarize the review comments and make a recommendation. And then will submit to the editor, and then go to the editor-in-chief, and then they will send out the email to the authors. That's the response and the author and comments and recommendation. There's a process until the acceptance or decline of the paper. Now, recommendation option for this journal, there are 4 options. First, called accept. Basically, author has no obligation to make any changes. The 2 or more accept in the first round. This very rare happen. I will show you the statistics number just after this. Revise for editor only. Practically accept some changes recommended before going to the press. Revision required. Also must make revisions or justify no revisions. Often used for split reviews. The most papers for the first round will fall into this category called revision required. Then there's the last category called decline. The paper cannot be resubmitted, must have 2 or more decline reviews, cannot have 2 or more accept review in first round. Actually, before editor pass the paper to associate editor, there's called initial manuscript screen. The editor can make some decision to decline the paper without going to associate editor. Decline because of the scope is not fit, or maybe transfer to other journals if the paper contains too much grammatical errors and all other reasons may not go direct to associate editor, may not go through the review process. Now, I want to talk a little bit regarding policy about conference papers. I think this is true for most journal, and submitted paper should contain at least 50% new contents. So if you submit a paper to the conference already published, if you want to submit the same paper to journal, typically is not allowed. Only if you add at least 50% more new content. That the remaining 50% not referred to previous published award. That for some authors, they try to expand the paper, just add the words, make it longer. That's not acceptable. What is novelty and the value added the review in the view of what has been published. Basically, you need to demonstrate the new stuff have been added into the journal paper in addition to the conference paper. Now here there's specifically regarding the TRB, because there's a lot of confusing regarding TRB papers. But TRB does include the paper into compendium. And for Aace Geotechnical Journal, the paper included in the compendiums are considered published, cannot submit to Aace for publication without significant additions and revisions. Now, also who intend to submit a TRB conference paper to an Aace journal must opt out of inclusion into the compendiums. Now, TRB now has the option for authors to opt out the inclusion in the compendium without including 4 papers. I think last year TRB allowed to have a expanded abstract into the compendium. That will not violate the 50% new content rule. Okay, technical paper versus technical note. The technical paper supposed to is a complete study, significant contributions. For Aace, typically allowed to 10,000 words. A technical note, a specific study, a limited contribution or focused contribution to that specific study. The word typically less 5,000 words. Here, let me show you some statistical numbers regarding the turnaround time for Aace Journal of Geotechnical Geoenvironmental Engineering. This is 2010 numbers, and show you, how much time taken from editor to associate editor to the reviewer. And I want to highlight the number really you want to care about, the time to the decision. Okay, but here, as you can see, typically take 3 to 4 months for this journal. But if your paper has been submitted for more than 3 or 4 months, I would suggest you contact this publisher office to try to check the status of your paper. If shorter than that, probably still in the process. The review outcome for original submission, even though this is a 2010 number, but it's still very similar. As you can see, except as is only 0.4%. Revised for editor only 2.7%. If we add those two together, really is 3.1%. Those are considered accepted. But basically, 97% paper will not be accepted after first submission or first review. The majority, basically, as you can see here, the revised for submission is 28 for technical paper, 8 for a technical note. If you add those together, really 30-some%. But I have been author for more than 300 papers. I know sometimes when you receive the review comments at the first time, you may feel the review is not fair, that you are mad. And if you have this situation, I would suggest you leave the review comment for at least for a couple of days or even 1 week. They go back to take a look again. My experience, when you start to review the papers, actually a lot of time you feel not bad, and not as bad as your first reaction. And then when you start to address comments, you will find out that most reviewers are very reasonable, and that they really help you improve the quality of your paper. But this is the review outcome for first revision. And as you can see, the number jumped fairly significantly. Now it's 61%. And the first one, you see only 3%. Now, if you resubmit back, then you got a very high percentage. But this is the point I want to encourage you. If your paper is not the kind for after first revision, I would strongly suggest you encourage you to revise paper carefully, resubmit to the journal. And the chance for next round will be very high. And the third round, and as you can see, this acceptance is 97%. The chance of getting higher and higher after your revision go from first round, second round, the third round. And you really need to take advantage of that opportunity if you are still given the chance to revise your paper. Okay, now let's talk about necessary components for a well-written paper. I'm sure Professor Xi has addressed a lot of those issues. And let me start with a list. You should have a proper paper title. The title should cover the content very well. And the title should be very appropriate and to also should be very attractive to the readers. When read the paper, say, oh, this is a very interesting paper, then we'll start to read it. You need to have a very concise abstract with important highlights about your study. You need to have a clear and convincing problem statements and research needs. That's in the introduction part. I know a lot of students, my students as well, complain it's difficult to start to write the introduction. I understand that. I went through that too. But you need to have a very clear, convincing problem statement. Why you want to do this research, what do you do the research for, and what do you try to solve, and then you should have a comprehensively in-depth literature review. I'll come back and talk about this, explain to you why. And then you also have a clear objective to provide new knowledge. This is important. If your paper just try to review other people's stuff, then you are not providing new knowledge. Providing new knowledge is an important component for a technical paper to be published. The well-designed experiment, theoretical, numerical model is important. For a lot of paper, I have been working together with other corroborators. I found out that when they conduct research or experimental study, they miss up something. And when you try to publish a paper with some not well-designed experimental, it will become very difficult. Theoretical derivation, same thing. If you miss up with the initial condition, boundary condition, your solution is not right. Numerical model, same thing. If you want to create a mesh, the mesh is too small, and you run the thousands analysis, come out not good result, will not be able to publish. Of course, that topic really deserves another presentation. And we'll analyze the data with meaningful results. You don't want to just put together all the data without any meaning. And this is very important. The concise contribution with clear contributions. When I dealing with the papers, a lot of reviewers complain about some papers, say that I couldn't tell whether they have made any contributions. But I think this is important for the reviewers and also for the author, for readers to understand what kind of contribution this paper really provide. The excellent presentation of all the above. This is very important. I will focus on that later on. Okay, the standards for acceptance for Aace manuscripts. The first be of value and interest to civil engineers, and be original, review of past practice, present information on current interest, probe fields of activities, be a thorough, thought-provoking study and contribute to the planning, analysis, design, construction, management, and maintenance of civil engineering works. To contribute to advance of the professions, be free of evidence of a commercialized and not having published previously. So I will get into detail about those issues later on. The key requirements for technical papers: original, that's very important, creative, and the theoretical and practical contributions, appropriate literature review, verification and justification, conforming the journal format, no commercial information. The common issues in paper writing, as I mentioned at the very beginning, the things that I present to you here based on my personal experience when I work with my students, the other co-authors, and through the servicing on the editorial boards, and I summarize those common issues here. First, insufficient literature review, insufficient basic information, unclear contribution, inappropriate citations, use of non-standard testing procedures, use of non-standard parameters, unclear assumptions, no justification verification, inappropriate presentation, grammar errors, word misuse. So I'll get into detail about this. So first talk about insufficient literature review. The purpose of a literature review basically is to provide the state of the knowledge to the readers, provide the basis for the current study, and also demonstrate the author's knowledge. This is very important. If you don't do very good the literature review, reviewer will think you don't know about this field. You don't know about what you are doing. But this is very important in the right, very good literature review to tell the reviewer, say, I know what I'm talking here, and make the reviewer feel confident in your study. The common problems, limited literature review, and the literature review only based on the knowledge in the local region or specific country. I think this happens a lot for some students. They have not read the international journal paper or conference paper enough. They only read the paper in their own country and summarize some literature just based on their own country in their own language because it is convenient to them. But that typically is not good literature review. The literature review only based on the author's own previous study. For some papers, not often, but some people only review his or her own studies. They list the majority of the paper from the author's published paper. That's also not good literature review. Now, insufficient basic information, general rules to provide the basic information sufficient enough for others to repeat the author's test or calculation to obtain the same results. I think this is a very important thing. You need to think about when you write a paper, describe your experimental test, what information other people should have to run the test exact same as what you did. But this is very important. But do not assume the reader knows the background because you are the author. You know what you are doing, but other people may not know what you use. The common problems is like not enough necessary information like groundwater table. For geotechnical engineering, groundwater table is very important. But if there's a groundwater table, you have to provide groundwater table. Even if there's no groundwater table, you mentioned the groundwater table not within the depth you investigate. Unclear soil parameters, like this cohesion friction angle. Because for cohesion friction, there's a different cohesion and friction angle. You can have a total stress cohesion, you can have a friction effective stress cohesion, you can have a peak value cohesion, you can have a residual value cohesion. But if you just provide the value, say cohesion equal to how much, friction angle equal to how much, the reader will not know what kind of cohesion you are talking about. And also talk about test method. Just for this cohesion and the friction angle of soil, as you know, you can use the directional test, or you can use a triaxial test, or you can use other test method. So you have to state in our paper, those parameters were obtained using what kind of test method. But even for triaxial test, there's called drain test, undrained test, or consolidated undrained test. But you have to specifically tell the reader what kind of test you conduct to obtain those parameters. Now, for other fields, I think you have a similar kind of things, but you have to make it very clear about the basic information. Unclear contributions. So don't general rules. Don't be shy of your contributions. At the same time, don't take other contribution as yours. Okay, so you need to be balanced. If it is your contribution, you fairly stated in the paper, say this is what you contribute to the knowledge, to the field. Common problems, harder to identify the author's contribution. So the review often complain about one paper, say I couldn't identify the contribution of this paper. For that situation, that paper very likely to be declined, because if there's no contribution, the paper will not be further considered for review. So take others' results of a formula without credit their contribution, it is cheating. Not a lot of times, sometimes author either forget it or intentionally forget it to put the other people's name associated with the formula. Whatever you did, this is a cheating. Basically, it's not acceptable. No support for authors' contributions, and some people claim that this is new, this is much better formula, this is much better method, without compare with other people's method or existing method. You cannot claim your method is better. You cannot claim you made a contribution to the new knowledge. But that's what I mentioned here, no comparison between the new and the old method. The inappropriate citations. But do not overcredit others, do not undercredit others. But here I have some common problems. Cite the author who has not made any contribution to the related study. That's not appropriate. Now, I also know when I dealing with a review of the papers, now some reviewers will ask you to cite their papers. But as author, you have the responsibility to decide whether you accept the review suggestion or decline the review suggestion. If the paper is relevant, you may be able to include it. If the paper is not relevant to your study, even though you may think this come from review, you can decline. You can say this is not related to my paper. Take others' results formula without crediting others their contributions, cheating, as I mentioned. Now, that's another misunderstanding when people write a paper, try to cut the paste from another paper, even though you put other people's name there, say this is from where. But without the quotation mark for copying a sentence is also not acceptable. And you have to put the quotation mark if you directly take a sentence from other paper that show this is not your sentence. This is other people's sentence. Without the quotation mark means you interpret other people's content, you rewrite the sentence. For that case, you don't need a quotation mark. But if you take direct the sentence from other paper, you have to use a quotation mark. Otherwise, this is also considered as cheating. Okay, don't cite a paper if you have not read it. Okay, but this sometimes is a little bit difficult, but especially for the very old papers, if a lot of people use it, maybe okay. But I found one example working with one of my students, and basically she cited a paper. Basically, it's the biaxial geogrid. This is a special geosynthetic study study based on the uniaxial geogrid. The author did not read the paper, and she saw that this is biaxial. Actually, that paper was based on uniaxial, and luckily I knew that paper, and I said that's not right. I asked her, have you read the paper? She said no. I thought this is biaxial. That's not true. But this is very dangerous when you take something out or just guess what something inside another paper. Okay, let's talk about use of a non-standard test procedure. This happens a lot, and I think it's okay to use a non-standard test procedure. Of course, if there's a standard test procedure, you will try to use that standard test procedure first, because that make your life easy and also make your paper, the results will be easy to be accepted by the other people, but we encourage innovations, right? But if innovation is something new, nobody have done that before, but you have to create some new. But that is okay, but you have to indicate the deviation from the standard method. But if you change something from here, from there, you have to indicate. That's what I made the change. That is different from a standard method. They will provide a detailed procedure for others to follow, especially the new stuff you create or you propose. You have to provide the detailed procedure for others to follow. The common problem, provide test result without describe specific test procedures. Okay, but here basically some geotech testing like a plate loading test, and there is the pressure and the sediment curve. Suppose you need to follow some kind of deformation criteria to run the test. And also there's a different test method available, like a load control, displacement control, and that may end with different results. So you have to say in the paper, say, I run this plate loading test, follow the displacement control method. I use, the displacement rate, just the number say 0.1 millimeter per second, and then people can follow your procedure. The scale and the boundary effect always is the issue when you run small scale tests. So I'll come back to talk about this a little bit more later on. Use of non-standard parameters. The general rule, avoid using non-standard parameters. Okay, unless those are new parameters you propose. Like a soil types. Typically, you need to follow the ASTM standard, AASHTO standard, or British standard. If the standard is not commonly used or commonly seen by most readers, then you have to kind of convert to the ASTM standard or AASHTO standard regarding soil type. Otherwise, if you talk a clay, maybe ASTM classified as a silt, but that's completely different material. And here basically talk about total stress cohesion, total stress friction angle. That's an obsolete parameter, and most common used parameter use undrained stress or effective stress. But there's some parameter regarding compressibility. Those are not the common parameters. Some of the audience in this presentation probably recognize those parameters used often in one specific countries, but in the international field, those parameters are not very common use. But they can be converted to those parameters called constraint modules. Okay, but you need to convert those parameters to other parameters well recognized by international readers. Unclear assumption. Don't assume others can read your mind. And of course, you did your research, you put it together paper, you know everything. But other people may not know what you are thinking. But you need to provide enough information, like an assumption. And there's a lot of assumptions you can make, but you need to make an important assumption regarding your derivation, your test, and your numerical model. The common problems here, like a non-considered model. When people publish a paper with numerical analysis without mentioning what the kind of considered model for soils, for structure, that's not acceptable. No boundary condition, no initial condition, and those are maybe obvious to the writer, but it's not obvious to readers, to reviewers. No justification. Do not draw any conclusion without any justification or evidence or data. And a lot of times, the author think this is very obvious, maybe not obvious to other people. So you have to show people why you drew this conclusion. The drew conclusion based on personal judgment, guessing, is not good things. But make a statement without presenting any evidence is also not acceptable. But you have to explain why you make this conclusion, why you make this statement. No verification. It is not acceptable if a new theory or solution is not verified by other results, test data. But sometimes people come up with brand new things that no other people have done before. what you should do. There's no results available, no data available. At least one thing you need to do, exam by parametric study. You need to show the readers, show the reviewers, you did a parametric study, show what kind of trends you are getting, whether those trends are reasonable or not. This is basic things you have to do. But to derive a theoretical solution without any verification or comparison typically is not acceptable. Applicability and the limitations. And all the theory and the empirical solutions have limitations and the conclusions. Even for experimental study, there are limitations and that they have conditions. But you have to be clear about the limitation and the conditions. But for some paper, as you can read, that they will put one section of limitations. Basically say, this formula was derived based on some limitation. This may not be applied for other conditions. And to examine the solution at the extreme conditions. For example, a solution for treated soil should be also valid for untreated soil if the effect of treatment is ignored. But you have to test your formula whether it will blow up. Some formula, like say, if I put this one parameter equal to 0, and the equation basically just blow up, and the 0 is a reasonable number. Or sometimes you can try the parameter, say, take it to infinity, see whether the solution still hold. But those are the very basic things you need to check whether your formula has any limitation, whether the formula really can apply for all kinds of situations. Okay, now let's talk about presentation. I borrowed one sentence. As you see here, I use quotation mark here from the reference. As a general rule, writing a paper, you need to have a good presentation. Write it in the style that is brief, active, precise, and simple. Okay, that's for basically for technical paper. So let's get into each one here. Brevity, basically the brief, means avoid unnecessary words and ideas, thus yields more precise writing. Okay, but sometimes people like to use like this is very large. Okay, so what does very mean? Can you define what is very? I think a large is enough. Okay, very small. What is very? Or sometimes extremely small. What does extreme mean? And that kind of thing is maybe not necessary. Okay, active style is more direct and lively than the passive voice. Okay, this maybe in the audience, maybe a lot of people will argue with me, say, well, I thought the technical paper has to be writing in the passive terms. No, that's not necessary. I will get into a little bit detail later on. And the active style is better than passive voice. Okay, but that's what I quote from others. It's not just mine. Position implies define all the concept of interest the first time. They appear and always refer them with the same word. I highlight the same word. Okay, remember what I talked about earlier on, the difference between technical paper and the fiction. The technical paper should be very clear. Okay, you don't cause confusing. But when you use the word, through a paper, if you can use the same word, it's better than use different words. That's different from fictions. Okay, if you use different words, it will cause confusing. Let me give you an example. Say in geotech, we're dealing with sediment or the building sediment. Some people like to use a vertical displacement. Okay, sometimes people use vertical deflation. In the same paper, if sometimes you mention this is sediment, and the other place mention this is a vertical displacement, then another place you mention this is a vertical deformation, the reader will be confused by you say whether they are same or different. Okay, but you don't want to cause confusion to the readers. That's the key. You don't want people to imagine what is this is different from another, or they are same. Okay, so a simple style is always better for technical writing. Okay, always try to write it in a simple way. I use one called plain language. People can easy to understand, and he said use a simple style. Okay, let's see. Non-professional presentation. General comment. Non-professional presentation shows that the author is not well trained, not serious about research and publication. But this is very serious consequences. then when you write the paper, it's not very professional. People, reviewers, look at it and say, this guy is not professional. This guy is not trained. This guy is not serious. Then as a reviewer, I say, why I should be very serious, read your paper. And they very likely end with decline because, you don't treat your own stuff very seriously, okay? But like inconsistent fonts and the spacing throughout the papers, especially figures. And I will talk about more about this. There's a lot of examples, and I'll share with you. Okay, inappropriate presentation of test data. You need to realize if geotechnical engineering basically has a lot of variability. The variability is the nature of geotechnical engineering. You have to accept that. You don't want to get a correlation R squared equal to 0.999. If you have that number, I will doubt about your result. And here are some general problems. Present a smooth curve without a data point, okay? And because if you show data point maybe not very consistent with the trend, then some people say, oh, I put a smooth curve. That's not acceptable because people don't know what kind of variability your data have, okay? So present a correlation without R squared is not acceptable. Okay, regarding R squared, the different fields have a different acceptable values, and for some field, to me, for geotechnical engineer, R squared 0.7 is pretty good. Some field even 0.5 R squared is also considered acceptable. But really depend on the field, depend on what kind of problem you are dealing with. Inappropriate non-definition of terminology or parameters. Do not assume the terminologies or parameters commonly used in one country are also used some other places. Okay, for example, like a composite foundation is very common in Asia, but not common in the United States. When you try to publish paper about composite foundation, you have to define it, have to describe at the beginning, what do you mean about composite foundation? Within the composite foundation, there's one parameter called stress concentration ratio. What is that? Basically, there's a stress on the column divided by stress on the soil. You have to define this when first to mention about these parameters, okay? Otherwise, the other people may not know what you are talking about. Abbreviation, full name should be provided for the first time use, and in the abstract, the introduction and conclusion in the papers. Like FHWA, everybody knows in the United States what the FHWA stands for, Federal Highway Administrations. But for other countries, they may not know what they mean, FHWA. You need to define this. If you write something in the abstract, you need to write the whole full name for the Federal Highway Administration. Also in the introduction, in the conclusion. Why you need to repeat that? Some people say, I wrote in abstract, I don't need to write again. No, because sometimes, they, for the citation, like index engineering complex, engineering village, when they do citation, they only take an abstract. When some people maybe start to read it from back up, some people like to start to read the conclusion before read the abstract, okay? Then if you have some kind of abbreviation in that area, people don't know. You have to have those full name defined in those sections. Make sure everybody, the review understand those terminologies. Grammar errors, okay. I would say it takes time to improve the English writing skills. Okay, and probably use a long sentence, passive versus active. I'll talk about this. And I have a suggestion. I would suggest those people haven't written enough paper just at the beginning, writing paper. I would suggest you keep at least a sample paper aside when you're writing paper. It is best if you keep a sample paper from the journal you try to submit, that you can see what kind of format they use. Okay, so, because different journals use different format, and you want to follow that. Okay, now let's talk about active versus passive terms. Okay, my suggestion, avoid using passive terms if active terms is possible. Okay, I try not to say everywhere you have to use active terms. Okay, but you try to avoid or minimize use passive tense. The reason passive tense is the voice of dead man. Okay, this may be too serious, but I put a question mark here, a quotation mark here. So basically, it's not good. Now, this is one example. You will see a lot like this, as shown in Figure 1. It's better to write in the way like Figure 1 shows. So you see, this is passive tense, this is active tense. Okay, this is another example from my students writing. In experimental study, the effect of EPS geoform on the distribution of vertical stresses about the rectangular concrete conduct under static cycle footing loading were investigate. Okay, so as you can see, when you read it's very difficult. This long phrase and then say or investigate. But it would be much nicer you say this experimental study investigated the effect of EPS geoform on the distribution of vertical stress above the rectangular concrete conduit and the static cycle loading. And this is also more balanced. You know, when you have verb and the subject, the object, a little bit more balanced than the passive terms. So I really encourage you, those to listen to today's presentation, try to use active terms as much as possible. Okay, now I know there's a question regarding past versus present tense, and different also have a different preference to use the past or present tense in their writing. It's very difficult for me to say you have to use the past tense, you have to use the present tense, but I have some general opinion from myself. But in general, present tense is used to describe the current status of research and practice, well-known facts and opinions. The present tense is often used in theoretical derivations. For passive tense, in general, passive tense is used to describe experimental tests conducted by the authors and the review work done by others in the past. Okay, those are the past tense. I'm sure there's some gray area. Sometimes it's difficult to judge whether this should be passive tense or this should be present tense. But for that case, maybe either way would be fine. Overlength title. Okay, concise title, as I mentioned, is better than longer title. Now, some journals now have a limit for total number of characters. Okay, I submit one journal. They say you only can have 90 characters. If you have more than that, the paper will not accept it. You have to reduce it, no matter what. And you need to try to write the concise title as possible. Okay, here are some examples, like research in the theory and application of the interaction principle between deep mixing columns and surrounding soils. Okay, I don't think you need the research theory application, and you can very easily revise as interaction of deep mixing column and the surrounding soils. Okay, and that's enough. You don't need to mention those words because it's just too long, too much. Okay, so this is an example of a long sentence. Okay, this also got from one of my visiting scholar. The highlight one, yellow one is one sentence. Okay, this is one sentence. What I revised here. Okay, so I took a lot of things, made a lot of changes, tried to change to the extra terms and break the sentence. But here I also quote one sentence from this author. Say, avoid complex sentences by breaking them into simpler, connected ones. Use the present tense as much as possible and to avoid too many acronyms. Okay, but that's what you see. If you have long sentences, it's very difficult to read, very difficult for people to understand. Numbers, let's talk about some numbers. Avoid starting with a number in a sentence, okay? Now, a number less than 10 should be spelled out, okay? No other number at the beginning of a sentence. This is the general rule from the English. Okay, present the point 1 before point 2, or present the figure 1 before figure 2. I read some papers, some people will start with the figure 3, and without mentioning figure 1 and figure 2. And I was wondering, where's the figure 1, figure 2? As you know, when you read the paper, you will follow the order, right? You want to see figure 1, figure 2, figure 3, figure 5, and 4, 5, that order. If you skip one figure, that makes very strange. You have to present. If there's a reason you need to refer figure 5 first, why not put it into beginning as figure 1? Okay. Now, a lot of authors treat this very casually, like 1.0, 1.00. Actually, they have a different accuracy, implication, and requirement. Let me give you an example. Like this is fact safety for slope stability design. Okay, and if say fact safety should be greater, fact safety should be greater than 1.3 is different from fact safety greater than 1.30. Do you know why? If fact safety is greater than 1.3, if I calculate fact safety 1.25, we're satisfied this requirement based 1.3 because you round off from 1.25 to 1.3. But for this case, not, because this one round off the third decimal. Okay. Another extreme case, and I also see this a lot in the class when students do the homework, and because you use Excel, they can generate millions decimals. The number of decimals should not be more than the accuracy of measurement. For example, soil specific gravity. You cannot measure like this one here. For most cases, people use 2.65 or 2.657. That's it, because you cannot measure the mass accurate enough to calculate your soil specific gravity that accurate. But all those numbers does not mean anything. But this only show you are not a professional researcher or professor writer if you show this kind of number. But it's not good. Okay, let's talk about example of common misused expressions. Those are like a don't, does not. This is a very casual oral language. Okay, it's not formal. You need to write as do not, does not. It's not a clear expression. You know, just for conversations, okay. If a technical paper, this is not very good. You may change like this phenomena or this result or this data. Here's another thing: the Skepton's equation. Typically, you have two options. One is should be changed to Skepton's equation or the Skepton equation. Okay, avoid use the form of the latter. Okay, a lot of international students like to use this because this really causes a lot of confusing, and sometimes it's difficult for people to know which one's the former, which one's the latter. But again, as I mentioned, at the very beginning, when you write a technical paper, has to be easy for people to read. You don't need the people's imagination. You don't need the people to suspect which is which. Okay, but try to avoid this phrase. Okay, here are the two terminology used a lot in the paper: increase and improve. Okay, increase typically relate to quantity change. But improves relate to quality change. For example, you can say increase payment life from 10 years to 20 years, but you cannot improve payment life from 10 years. But however, you can improve payment performance. Okay, but there's a slight difference there. Okay, redundancy. But do not use words of the same meaning in the same sentence. This is a very, very common use by people. Okay, say in addition, there is also sufficient length of reinforcement. In addition, also the same. But you don't need to use both. You only need one. In addition, or use also. To use two, it's not right. Okay, here I show you this problem here. Okay, I demonstrated figure 5 shows that the load capacity of pi decrease with an increase of time. This is because I can interpret this many ways. Okay, there are many possible interpretation for this. I can say this figure, this capacity, this pile, this time, which is this. Okay, but you need to be basically very clear. You put the word after this, make sure people understand what this means. Okay, this results. If you want to talk about overall, that this result, this phenomena. Okay, uncommon symbols for or format. Some of the audience may recognize those symbols used in some countries, but those symbols are not used very often in international journals or conference papers. You can change it to this. You can change it. Now this is another one. Okay, A divided by B dot C. In some country, they know what's the order, but for me, it's not know whether you A divide B times C or A divide by B times C. Okay, you have two different options. It's better you put the parentheses there to make sure which was which. Okay, and also you can have A divided by B times C, right? There's different things. Just make it clear. Reference in text. General comment. Different genre may have a different style of reference in text. For example, the author's name, a year for publication, number of the authors, the order of the reference, the year of publication, early or later, the order of reference. Okay, and I prefer, if you in the literature review, if you want to refer past study, I prefer you use the early one first, then the later one, then the later one. Just as I see for one study here, you want to give the credit for the early one first. This is 2007, then give the 2009, then give the 2012, then give the, now, if you have the same year, what do you do? Based on the alphabet of the name, the A go first, C go later, okay? That way you give appropriate recognition of those authors. So if you start with the 2012 first and 2007 later, it sounds like you give the 2012 more credit than 2007. But this is the proper way to do. Okay, location of tables and figures. The table and the figure should be placed in the text after immediate connect to where they are first mentioned. But to avoid spread them between pages, okay? Their insert may be delayed but not advanced, okay? Now let's see here. I have a figure here, the figure 1 here, mentioned in the text, but this figure here. Why not move the figure underneath here? Why people need to read all through here, then come to find your figure 1? So that's not the good location for you to put the figure. Graphics and color in color, photos in color. Nowadays, because we use a lot of electronic one, maybe this problem become a little bit less, but I still would suggest the graphic and the photo maybe in color. However, do not use the light or pastel colors such as yellow, light green, and as preceding books or journals will be published in black white for most cases if you print out. And even for you, if you want to print out by computer, you may not see those lines. As you see here, like this one, this light blue one. When I print out this figure, I couldn't see the figure. This curve. I said, where's the curve? Oh, this is a light color, and you do not see this. Okay, it's a good thing to also use different symbols to differentiate between different curves. Okay, this is regarding the font size, the commercial information. As you can see, I don't know, you can see here, it's really hard to see. But we submit a paper to Aace Journal of Geotechnical Engineering Environmental, and we attach this figure first. And then the editor asked us to get a copyright from the software company. They say you use the software company's name here, we have to get a copyright this. But for your paper, really it's not necessary. You already mentioned in the paper said, you use what kind of software to do the research. But really you just can cut out this piece, put it into paper rather than show their logo, show their name, show their company, because for the publisher, consider this is a commercial, okay? But commercial is not allowed in the published paper. Overlap of font with drawings. You can see here, the font is overlap with lines, will make it much difficult to read. Okay, you should move away the font to some other place and not avoid, because when you print out, you will find out this light blue color may become dark, and then the 1.5 M you will not see the M, and that kind of things you need to consider when you write paper or prepare the figures. Point the arrow to right position. Okay, like this one, as you can see, the arrow point to the air. I don't know which one you point at, especially there's 2 lines here. Which line you're pointing to? And here, same thing, the toe and the arrow is past this X line. And that's not a good presentation of the figure. Okay, you need to point to the exact location of the curve you really want to point to. Inconsistent symbols. On the y-axis, you have a G. But in the figure, you have a G1, and then you also have a G2, G3, G4, G5. And this, I don't know which G you are referred to here, but you need to be clear about what G this refer to, okay? Inconsistent scale. This is a very common problem. And as you can see here, this scale uses 300, this is 200, and this is 40, this is 60, okay? It's very difficult for reader to compare between those two cases. Basically, those are two cases, okay? You need to use this 300 for this case, 60 for this case, and then you can make a good comparison. So this is inconsistent scales. Inconsistent unit. Here, basically, I got from one paper, and originally they even don't have a unit. Okay, so based on the field study, the foreign relationship was established. The K has this unit, and the E has this unit. They are not consistent units. Okay, but you need to be careful with this. I know for some empirical correlation contained inconsistent units, but that's fine. But you have to write out the units. Otherwise, it does not make sense. Okay. But otherwise, when you put in the different units, the results are completely wrong. Because we know we have metric units, we have English units. If you use different units, you will get the different result. Okay, confusing designations. Avoid use the same letter symbol for different meanings. But here, basically, from one of the papers, it test A, then area of column A, cross section AA. Then when you mention the paper, then I don't know which A is which A. And you can easily change it to test 1, area of column A, cross sections 1-1 or II. Okay, but that will minimize the confusing to the reader and the reviewers. Okay, be careful with advanced technology. Okay, this paper was written by my student, and he used EndNote. I know a lot of students at university use EndNote, and they will pour some information there, and then you can very easily insert to the paper. Then when I reviewed the paper he put together, and then side with this one. Okay, you know this is me. But they put the G as the last name, Han initial as the first name. But here's the right. And the basically advanced technology, they sometimes difficult to identify which was which. And then you really need to be careful. This I told my students, you know my name? Knowing my name, okay, this is the case. He explained to me, he used EndNote. Okay, inappropriate handling review comments. The general suggestion comment, understand the intention of each comment, okay? So you have to understand why the review asked this question. What does the review really want, okay? So treat each review comment seriously and think through when you respond. Do not delete the content question by reviewers without any response. And let me come back a little bit, understand the intention of each comment. Sometimes the author does not understand the review comments and then write the very long response has nothing to do with the review comments. And sometimes it causes even more problem because in the response, but generally more questions to the reviewers. So that is not really good, will not help you. So you need to understand what the review really want, and then point by point, try to be concise, brief, and to point to the review comments. Okay, to come back to the last one. Sometimes the reviewer point out the problems in the paper, and you have to address it. Either you reanalyze the data. Sometimes the data is not right, and you need to double check the data. But you cannot just delete the data, delete the content without any response to the reviewer. For that case, this paper must be rejected because you try to fool the reviewer to get accepted. That's not acceptable. Some common review comments I want to talk a little bit. This is very common regarding boundary effect, the scale effect, calibration of sensors, calibration or verification of numerical models, verification of theoretical solution, force equilibrium. By going to one by one in detail. Boundary effect, especially when you do small specimen tests, you always face the issue regarding boundary effect. The reviewer will have this in mind. We'll ask you if you not to appropriately address the boundary effect. So typically, the size of box or chamber or sample is at the least 5 to 6 times the object of interest. Like this one, if I do like a triaxial test, you need to see what is the maximum particle size. Your sample size, the diameter of sample, has to be 5 or 6 times the particle size. If the particle size is much bigger than the ratio that I define here, probably you have a boundary effect. Okay. Now this is like a plate loading test in the box. Your box size should be at least 5, 6 times your plate size. Otherwise, you have boundary effect. Now, sometimes you can use some verification to demonstrate there's no boundary effect. For example, you can put the earth pressure cell on the side of the box or the bottom of the box, and on displacement, you show if you apply pressure here, you will not see any change of the pressure here to demonstrate there's no boundary effect. Or you can do like a parametric study in the numerical analysis to demonstrate the boundary effect is minimal or eliminated with using module model size. The analysis uses this size, and then you double the size. See whether the results are similar or same. If the results are the same, then you demonstrate, say there's no boundary effect. Okay? Scale effect. Sometimes we try to reduce the small scale. It's easier to conduct, but often encountered with questions. If you use small scale, you always need to do dimensional analysis, scaling, and similarity should be performed to select appropriate materials. Now, another thing you also can do is numerical analysis to address the scale effect issue. But if you do a small scale test and you got the results, people will ask you, the stress level for soil maybe not appropriate. You can use a small scale with numerical analysis. They match each other as a calibrated numerical model. Then you can enlarge the model, basically enlarge your small scale to full scale. And you run the analysis again, see what kind of effect. Then from there, you will know what is the scale effect about this. Okay, calibration of the sensors. Suppose all the sensors you put it into measurement should be calibrated. Okay, low cell, I think is a regular calibrate. This is dealing with calibration of strain gauges on geosynthetics. As you can see, this is a geosynthetic hanging there. We put the weight, try to apply the tension test, and then we want to measure the strain in the different geosynthetics. This is different products, and then we will see the global strain basically use the dial gauge. The local strain use the strain gauge. As you can see, for different geosynthetics, they have a different relationship. For this one, you see it's like 1.29 times the global strain over the local strain. So if you measure strain gauge from here, you need to modify 1.29 to get the global strain. So that should be calibrated. Okay, another thing for numerical analysis, you need also calibration or verification. But you need to measure, this is basically show you the calculate, the numerical results, and this is the field test data. They match pretty well. And here I have two double check. This is a software calculation. This is a numerical calculation, and this is a field calculation. You see all three match pretty well. You verify it. Verification of theoretical solution. That if you don't have experimental data. This is an example showing you have a simplified solution proposed by this one of my former students, Dr. Ling, and then compare with the numerical results to see whether they match pretty well. Then you verify the theoretical solution is a good solution because there's no field data we couldn't find to verify the numerical analysis to verify this. Force equilibrium. But this is a basic thing. So you know Newton's law, and the force has to be equilibrium. But here basically show you a test we conduct. The plate loading test. You have a loading plate, apply load. Then you have the earth pressure cell here. This is for different sections. The apply load, and then you measure the earth pressure. Then you got distribution. So how do you know your measured results are correct? Even though you calibrate the earth pressure cell may not still be correct. But what we did, basically we calculate the area of this, okay? Basically this is force times the distance calculated area. The area should be equal to the force you apply, okay? if it's not, that means there's some error. Now, of course, there's some acceptance error range. If an earth pressure measure is like a 10%, 20% error, may be acceptable. But if like 50% error, then will not be acceptable. Okay, so that's something you need to check with force equilibrium. Okay, how to handle bad data? If you got the data really bad, what do? If one way delete it, that's not good. But you have to be honest. Okay, and this is the one paper we published. We know this data is not good. We still report it, and I put the question mark state. We thought about this, and hopefully the bad data is not the most important one. Okay, otherwise the test should be repeated or not publishable. Now this is a field test. It's difficult to repeat a field test, right? Conduct some analysis to verify the bad data. What we did here, you see, this is the profile, the last profile, and this is our computer, the analytical solution, the distribution. Okay, based on force equilibrium, you know this point suppose should be somewhere here, not there. Otherwise, the force will not equilibrium. Okay, but this is the theoretical prediction. But this is data is way off from the theoretical prediction. But this is bad data. Okay, so you need to offer some reasonable explanation. If you identify the problem by yourself, rather than identify with the reviewer appreciate. Okay, so this is very important. The best way to improve writing, I'm almost to the end of the presentation, just keep practicing and learn from others, learn from mistake, but do not keep repeat the same mistakes. Okay, this is the important. Sometimes, when I review my own students' paper, he or she keep repeat the same problem I point out many times. I was getting upset, frustrated, heart pressure, whatever. You need to be careful. You need to learn from mistake. Don't repeat the mistake again and again. Okay, now I reach the concluding remarks. And the publication of a well-written paper requires time, effort, and patience. Okay, should be well-written paper should not only contain a clear contribution to current knowledge, but also has excellent presentation. Okay, a well-written paper with proper handling of review, comments, and revision can increase acceptance rate and shorten publication time. A well-written paper can also increase the number of citations and make more impacts. Improve our technical writing skill takes time. Practice and learning is the best way. That's all what I have. Thank you very much for listening to my presentation. If you have a question, we can talk. This is my contact information. If you want to reach me by email, it's jehan@ku.edu. Thank you very much.
Thank you, Dr. Han. A very nice presentation. And now, if you have any questions, please input on the questions box, and we will answer your question. And I also invited Dr. Shi, the presenter of our first technical writing webinar, to our panel, and so he and Dr. Han can answer your questions. Okay. First question: does one submit to more than one journal at a time to increase chances of acceptance?
I think the question probably asks is whether it can submit the same paper to two journals. The answer is no. You cannot submit the same paper to different journals. This is not acceptable, if that's the intention of that question.
Would you please re-explain the reference ordering?
Okay, I think that the one I explained is mentioned in the text, not in the reference list. But in the reference list, different journals have a different requirement. As I mentioned, some journal basically lists the author based on the alphabet order of the first author. And some journal basically lists based on the numbers, 1, 2, 3, 4. But to me, in the text, when you mention about other people's study, you need to give appropriate credit to those people conduct research. But you need to give the person who conduct the research earlier first, and then give the research conduct the research later. Okay, that way I think it's appropriate to treat the contribution of the researchers from the historical point of view.
Okay, and next question. This is not one. On the assumption of how much background knowledge can be assumed from the reader or not, how much should we stick to that assumption? For instance, if I'm solving an equation numerically in a paper, do I have to forcefully include the explanation of the Newton-Raphson method for numerical solving an equation, or on a payment design, may always define what the goal of payment design is?
Okay, I think this is a very good question. This really depends on which journal you submit to, and this is of course a judgment call. If you submit your paper to the journal, basically dealing with mostly experimental study, your paper is more numerical, I think you need to have more explanation. But if you submit to the journal is focused on numerical analysis, probably you don't need to explain very detailed, basically mention the method will be sufficient enough. Also, like some mechanics journal, they already have a basic knowledge about this. But this is a very, it's a depend kind of situation. If you submit to like a material in civil engineering, probably you have to explain that method a little bit more detail.
Mm-hmm. Yeah, the same asker mentioned another issue, similarity. Whenever we put a figure, do we always define the R-square coefficient, or can we just assume the reader knows what R-square is?
That's a good question. I mean, a lot of people like define this because R-square is not a long definition. It's a very long definition, of course, you take a lot of lines, but this one you can very simple define. I think that most people know it, but I think it's better to define it. I would not say you must define it, but I think it's better to define that as well.
There are a few questions regarding the presentation slides and the recorded webinar. And again, I want to let you know, after today's presentation, we will gather the recorded webinars and also PDF version of the presentations for both two webinars and post on CESTiCC, ISCIP, and also Inspire's websites. Okay, next question. Can we use different versions in the same section? What should we do to ensure the right version? I'm not so...
Yeah, I don't know the question.
I assume they ask, because you talk about the different tenses, like past versus present tenses, I assume maybe they ask different versions. Maybe it's about this. I'm not sure. Anyway. Okay. Let's go to the other one. Another question about the citations. When we are referencing to a paper, by a international organization, for example, Federal Highway, do we have to refer to it as Federal Highway, year, or authors of the paper, year? And in the reference section, we point to the paper by authorship and then mention is a report by the X organization. Do journals have consensus about this?
Okay, I think this is very, very good question. Now, I don't know the audience know that for federal highway document or public document, it's public. And suppose if you use a figure inside the public document, you don't need a copyright requirement. But if the public document cite other people's figures with copyright, you still need the copyright. Okay, that's the first thing. Second, like a federal highway document, some federal highway document have authors. Some federal highway document do not have authors. Okay, even the federal highway document have authors, you can still reference as a federal highway. You can do either way. You can reference the author. Also, you can reference like a FHWA, like a 1997, something like that. But you still need to list the author in the publication section. The reason because that document really belongs to federal highway. It's not belongs to the author. But this is also why you don't need a copyright to use the figure in the public document, except those decided from other copyright document. I don't know that explain clearly, but that is the way you can do. But I didn't address the copyright in my presentation. But as you know, copyright is very important, and the more general really very much want you to get a copyright when you use the figures. Maybe this is an opportunity for me to talk a little bit another things. Suppose if you modify the figure, but you don't need a copyright, but there's a degree of a modification requirement. Okay, you cannot change one word and then you say I modified, or maybe delete one line, say I modified. But you should really make a technical change in the figure. Then you can consider this you modify. Then you don't need a copyright from original paper or original author. Okay.
Okay. Next question. If I have many data points in a graph with considerable fluctuation in the data points, can I show the smooth graph without showing the data points?
Of course not. Of course not. And actually, for that kind of situation, happen a lot. As I mentioned, even though I mentioned geotech, but I think for civil engineering, it's the same thing. There's a lot of variability. So people understand that. So I think some way you can do, you can have a general trend, and then some people say that 1 standard deviation, 2 standard deviation, show those lines, give the range of those lines. And I think people will understand, will appreciate the way you are doing like this, rather than just show a smooth line. That's completely not acceptable.
Thank you. Any other questions? I think this attendee was asking a lot of good questions. How far back are we to go with the literature review, and how do we manage to keep a proper literature review for a long-run project, which may also be involving elsewhere?
Long run, I don't know run, but that's another question I can't understand. So when you conduct literature review, for the journal, for the reviewer also want to see latest publication. Okay, but that's also important, though, especially if you can find it. Of course, if you cannot find it, there's another issue, another matter. But you give the historical perspective, and then you will go to find some latest research, because that is the current state of practice or current state of art. You have to include those papers. Now, there's another thing I may mention a little bit. I don't know. I have a mixed feeling, but some journal now require you cite the paper from that journal. Okay, I don't want to get into too much detail about this. There's a logic behind that. Basically, they want to demonstrate your paper really relevant to that journal. Okay, whether it's appropriate to the readers of that journal. But I would suggest at least you need to demonstrate your paper is relevant, and cite at least a couple of papers from journal for that journal if you can find it. Okay. But I will not really cite a lot of papers for the same journal if not relevant, and try to help them increase the impact factor, whatever.
Yeah, but how far back are we to go with the literature review? Like say, I think we always need to review the current practice. But how far back? Like say, if on a certain topic, do we need to go trace back to the reference or reports back to 1950s or even earlier? Or that's another question the attendee was asking.
I think this is a very good question too. So this depends on whether the theory or the method is still used at the current state. Okay, let me give you an example, like a ranking theory or spread theory. Okay, that back like a long time ago. We are still using it. But you're supposed to decide it, right? I mean, even though it's more than 100 years ago, and you still decide it. But if some method, proposed but not used anymore, it's not necessary you decide. You need not doesn't need to go back. But it really depends on different situation. Also, whether your study is relevant to that publication. For example, if somebody did research like 200 years ago, okay, then you pick up from that research. That may happen. Somebody proposed something and nobody noticed or nobody really care about it, and then suddenly you say, "Hey, this is really nice things. I want to pick up and I want to continue research of this and get a good results." You can, of course, you need to cite back to that paper, even 200 years ago. But this really depends.
Okay, next one. I think that's what I mean about the previous attendee's question. Can we use different tense in the same section? What should we do to ensure the right tense? For example, in the introduction section.
Yeah, of course you can use different tense depending on what you try to describe. As I mentioned, if you describe the current status, and you can use the present tense. If you then mention the past stuff, you use the past tense. Right? I mean, yeah, in the same paragraph, that's no problem. It really depends on what you try to describe.
Okay, next one still regarding the how to write the literature review. If the author is conducting a long-run project, the project may take years to complete, but between the moment finished, my background review before going fully into original work, other stuff may have appeared in the same time. So how to still complete the literature review with showing current knowledge, latest knowledge and practice.
I'm not quite sure about this, but I try to answer in this way. When you cite the paper, let's say you say you have a long project, you may write 2 or 3 papers. But for the first paper, you conduct a literature review very thoroughly, literature review, and the second paper, whether you should go back and do another thorough literature review, I would say not necessary, and you can refer back to the first paper. Basically said, we already conduct a literature review, having reports there. Of course, the second paper, you still need to have a literature review, but probably focus on most recent study done by yourself, done by other people, and I think this is the way to do it. You don't need to repeat the things you already wrote in the early paper. I don't know whether that answers that question.
I think I can add a bit. I think the attendee was asking a situation. For example, when we work on a project, I think in most cases the first phase is to conduct a literature review. But in the meantime, the project will, for example, if the project will take 2 or 3 years to complete. So, but generally students will finish literature review as the first phase. But in the meantime, from the beginning till the completion of project, and the writing, the final report will be the last phase of the project. So in between, from the beginning of the project till the end of the project, at the same time there will be also other studies on the similar topics will be published. So I think that's the attendee, the situation which the attendee was asking. For example, if you already wrote the literature review at the beginning, but now you have kind of more.
Oh, you can update. I mean, when you write a report, if that new thing come up, you add it out. That should not be a problem. Now, there's another thing that I may relate to this. As the person said, you already conduct a lot of literature review stuff. Some people like to publish a paper just based on literature review. Okay. Now, let me offer some my own opinion. Typically, some journal like some well-established researcher to do that, and basically say that person have done a lot of research in this area, like to write some kind of state of practice or state of art paper, basically to summarize all other people have conduct. And that does not mean say students cannot do that. Okay, but if you are students still in the learning process, the review will be more careful. Try to accept the paper like this come from a student. But if you really write an excellent paper, I don't see reason why other people not accept it. But another thing you need to understand, not to just pull everything together. Okay, but you have to do some analysis. If you use other data, combine the data, do some analysis, and then also you need to offer your own opinion, okay, based on the summary of the data from other people or other literature, not just compile together. That's not the good literature review paper. Okay, now maybe okay for you to write a dissertation to compile what the other people do, but if your paper, remember, paper has to have a contribution to the new knowledge. But you have to, from the existing study, try to find some new knowledge or common things, then can share with the readers, say that you find something new from studies.
Okay, thank you, Dr. Han. In your presentation, I think you also referred some references. For example, Wildres 94. So is it possible for you to collect a list of references so I can put it together as additional information from those webinars?
Okay, I think that this is a very good question. I don't think I have read enough about the other people writing articles. I think Professor Shi may have done that, can put something together. Another thing that I would suggest, now the website is so popular, so powerful. But if you write something you are not sure, You can type some word into the website and then try to see what the common sense. Okay, there's will be some discussion. Some website also offer some guidance to how to write a paper, how to use words, and a lot of time, even me, I'm still doing that. This is why I say I'm not an expert in English. I'm still doing that. If I'm not sure, I will go to website, type in one versus another. If you say, okay, 2 words, I'm not sure which one is more appropriate. Then you can type those 2 words in the website, and it will pump out a lot of discussion or some instructions. You read it, but you have to make it your own judgment, okay? Which one is right, which one not. But a lot of time they have a common agreement or sense, suggestion that you can really rely on. But I think this is a very good. That may take a little bit of time if we really want to put together some literature for technical writing. Maybe I can work with the Professor Shi. Maybe we can put something together.
Okay, great. Thank you so much. Very helpful and excellent presentation. I think we addressed all questions. And again, the recorded webinars and also PDF version of presentations will be uploaded to CESTiCC, ISAIP, and Inspiring websites for you guys to get more information. And I think that's all for our webinar, technical writing webinar series. And if you have further questions, and I think in both presentations, you have Dr. Han and Dr. Shi's contact, and I'm sure they will be very happy to answer further questions if you contact them by emails. Thank you very much. Have a good rest of the day. Thank you very much, Dr. Han.
Thank you.
Bye-bye.
All right.
Goodbye.